you a bit more about how to start problems and how to use dimensional analysis to solve them throughout, okay? So on soccer tape, you'll notice it gives you feedback every time, so it hopefully kind of gives you a little like pat on the back every time you get something right. And we'll usually have one soccer quiz a unit. We don't do it too often. All right, so dimensional analysis. Ready? We are going to, I'm going to kind of, you guys tell me if you get it as we go, because I want you guys to practice as much as you can in class with my feedback and each other's help. Dimensional analysis, it's a really fancy way of just saying chemistry math. And in chemistry math, we use numbers and units. And we've talked about conversion factors, I think, 3 times now, so I'm not dwelling on this much longer, because we're going to actually implement them now. And conversion factors, another name for it is just fractional units, and it's just because it's written as a fraction. And you'll notice that I'm using some common ones like grams per milliliter, which is density, and then some ones that are less common to you, grams per mole, and that's actually called molar mass. And molar mass is something we're going to really dive into later, but I can give you the conversion. I can tell you what the equivalency is, and you just accept it for now, and you can use it, but then later on we're going to understand why we're using it the way we're using it. Another one, it's not JK, it's joules per Kelvin. What are each of these units representing? Joules are the unit of what? Electricity. Electricity or energy, right? I'm just going to do energy in general. And Kelvin is temperature. So we can relate all kinds of things. And we call them equivalent because they're equivalent in some way or form. Just like 1 foot is equal to 12 inches. I'm telling you a certain number of grams is going to equal 1 mole, or a certain number of joules is going to be equal to 1 Kelvin. So these are just things we're now establishing as equal. So, dimensional analysis. This is my favorite part. Okay. So here's the first one we're going to start with. And there's some that you're going to be very familiar with. And I want to give you your process. So whenever you're reading a problem, you always find your given. And so you're given in this problem, and this is a very short problem. The given is the singleton. One piece of information. It's usually not a conversion factor. It's not going to be written as a conversion factor or with a fraction. So in the problem, 40.0 centimeters cubed of aluminum is equivalent to how many grams? My given is just a single fact. And then, maybe on this, in the same question, maybe in like a chart above, it'll have a bunch of conversion factors listed. So in this one, it's density, and I know this is a conversion factor because it's written as a fraction. It's a fractional conversion. So that's kind of the glaring point you should see as to what makes it a conversion factor, is it has some sort of fractional unit. And the question, the actual question, is asking for how many grams. So that's when I usually write to the side question G for grams to indicate what I need to get at the very, very end of this problem. So whenever you're starting a problem, always start with your given. And so I'm going to start off with 40.0 centimeters cubed. And I want to solve this via dimensional analysis. And this is kind of what we started yesterday, where you put on the next step your conversion factor, and you're converting from this unit to a new unit, but you're not actually changing the number or the measurement really whatsoever. You're changing the way it looks. So if I see this, I know that this actually can be written as 2.7 grams per centimeter cubed, because that slash just means fraction. So if I need to take this and put it here, if I put it directly as it's written here, is that going to serve its purpose of canceling units? Yes or no? If I put the gram on top and the centimeters cubed on bottom. Yes, because I need the centimeters cubed to cancel with these centimeters cubed. And that 2.7 is sticking to the gram like glue. You can't move it. And that 1 is going to be with the centimeters cubed. So I'm writing it as is, and that's going to serve its purpose to convert. And I convert to grams by canceling centimeters cubed on top, centimeters cubed on bottom. So what's 40 times 2.7? Calculator, be an active participant here, okay? If not, you get sleepy. 108, right. So it's 108 grams. How many sig figs should this one have? 2 sig figs, so round it to 2 sig figs. How would we round this to 2 sig figs? You start from the left, and you have to record the 1 and 0, but what happens to the 8? It's going to round that up, so this is going to be recorded as 110, 110, because it's not, you can't record it as 10 or 1.1 or anything lower than 100, because it's definitely over 100. And we're going to round it up to 110 to represent these two things here as sig figs. Okay, we'll keep working on rounding. But that's how we do dimensional analysis. And you may have solved this differently in the past, like yesterday or the day before, by doing proportions. But we're going to try to stray from that because this is a tool we'll use pretty much for eternity in chemistry. Okay, so you tell me on this one, I'm starting you off with what? What's your given? 40 grams this time, right? So 40 grams is my given. And when it says how much space, what unit is it asking for? It's asking for volume, but what unit? Sure, let's go with centimeters cubed, simply because that's what's given to me in my conversion factor. We're using the same one, so 2.7 grams per centimeter cubed. It's just not really on the screen here. So 2.7 grams per centimeter cubed. So if I start off with my given, 40.0 grams, how do I write this in a way that cancels out grams? What's going to go on the bottom? Yes, the 2.7 grams goes on bottom. So that means I have the power to flip the conversion factor as needed. And the 1 centimeter cubed, which is here, goes on top, allowing my grams to cancel because they're on top and bottom. And what's that in terms of centimeters cubed? Calculate. So you're taking 40 divided by 2.7, or 40 times 1 divided by 2.7. 14.81, I'm going to stop there for a second, centimeters cubed. Okay, that's not my final answer yet. How many sig figs do I need? 2, because this one has 3 sig figs. This one has 2 sig figs. So I need to limit this to 2 sig figs. So what would I round that to? 15. There we go. Because the 14.88 runs the 4 up, so it's 15 centimeters cubed. Okay, so this is similar to kind of what we were approaching yesterday. Let's talk about units we've never seen before. So I can give you puppy dogs, kitty cats, and donkeys, and you can do it. If I say 4 cats are equal to 1 donkey, and I say that's an equivalency, you can make it a conversion factor, right? So you can really do it with anything, and it might make maybe other parts of your life easier if you need to solve for something in math class. So I'm giving you density, molar mass, specific heat, heat of fusion. What the heck is heat of fusion? Nobody cares, but here's the equivalency. 40.65 kilojoules equals 1 mole. So I'm telling you your definitions now. These all can be used however you need to get from start to finish, right? So I'm explicitly telling you that 40 grams is our starting point and moles is our question, right? So which of these conversion factors has both of those in it? Molar mass, right? So I'll kind of demonstrate this first one for you. This one's a one-step one, okay? 40 grams. What do I write next to cancel out grams? So this is, you told me this is what I'm using, right? So the 18.2 goes with the grams, and that's with 1 mole. Okay, so 1 mole on top, and what goes on bottom? 18.02 grams. Okay, and that gram and gram would cancel. What's 40 divided by 18.02? 2.2 what? 1 what? 9. Sorry. Okay. I have my rounded one on here. Moles, and so we've gotten to moles, and then how many sig figs? 3. So round that to 3 sig figs. 2.22 moles. Good. Okay, so you can select from a chart the appropriate conversion factor because you understand that you're looking for one that combines both of these. Okay, let's do a little bit of a harder one. Let's go from milliliters to molecules. All right, so we're going from milliliters to molecules. Eli, where's the middle from? Thank you. Milliliters to molecules. Do you see anything with milliliters and molecules in here? Together. No. Okay, so let's make this puzzle work. I know I have to have milliliters in my very first conversion factor because that's what I was starting with. Which of these am I going to start with? Which are the conversions? Density. Okay, so I'm just putting up number 1 right there. Okay, so if I get from milliliters, 80.4 milliliters, and I get to grams using this, now I'm stuck in grams, right? Now I'm stuck in grams. How do I want to proceed from there? Maybe with molar mass, right? Okay, because I need to eventually get down to this molecules thing. So number 2 conversion factor would be this gram to mole ratio. And so now I've gotten rid of grams. I'm in moles. What's my next step? Because I'm in moles and I want to get to molecules. Moles and molecules are not the same thing. The last one, right? Sorry, it doesn't have, this is Avogadro's number. Sorry, I don't have an identity for it. So this would be our 3rd step. So you can see they start to build. And it's just a puzzle. You're looking for what you have, what you want to get rid of, and then move on. So like a mine, you're going to go the whole way. So I'm going to kind of minimize the screen here. And you guys tell me where we're going, okay? So we're going to start with 80.4 milliliters. And what am I going to write on the top? My top of my fraction. And I'll move it back up in a second. Okay, so the grams on top, milliliters on bottom. So 0.9994 grams per 1 milliliter. And the only purpose of doing that is to cancel out milliliters here and here. Okay, so good. So now you see that we have grams, right? And we got to get rid of grams. So where is it going to go in my next fraction? Where is the unit of grams going to go? Bottom, right? And then that, you can't see it either. Oh, yes, you can, right there. Okay. So this was number 2 for us, and so the gram actually has a new number that's associated with it, right? So I don't get to put 1 gram down there. What do I put? 18.02. Good. And that's per how many moles? 1 mole, because that's what this conversion is defined as. So we don't even really know what a mole is all the way yet, but we can use it just for cancellation purposes. So now we've gotten rid of grams, bless you. Grams were on top here. We decided to put it on the bottom here for our next conversion because we needed to cancel it. Now, nobody cares about moles. We want to get to molecules. So then I need to put what on the denominator of this next one. In this case, yes, you're right, 1 mole, and that's because of the defined conversion. 1 mole here, and what goes on top? Times 10 to the 23 molecules. Okay, so that's going to then show us the mole and mole will actually cancel, and then we're allowed to say, hey, we are at molecules, done. Okay, right, we've gotten to our final destination. But we need to now calculate. So this is where it comes, some people have a hard time with it, and you can help your neighbor with it. How would you put this in your calculator to find the right answer? Depends on how math-minded you are, okay? To me, I don't remember not knowing how to put this in my calculator, but I'm not you. So what would you be putting in? So you're going to start with the big guy? Okay. I'm just going to go in order just for easiness sake. I would put 80.4 times 0.9994. And I'm dividing by 1, but, it doesn't affect our answer. And you can hit equals now, and then what would you do? Divided by 18.02, and then you could hit equals, and now you're going to have, tracking 3 times, or you can just all in one big swoop. So divide by 18.02. Alternatively, you could have multiplied by 1 over 18.02, because that's the same as dividing. And then you multiply by 6.02 times 10 to the 23rd. The only issue I ever want you to really consider is where do you need parentheses? And I always put parentheses around these things with scientific notation, because on the numerator, it's not a problem. Everything's multiplied across in the numerators. But it's when you get in the denominator. If you divide by 6.02 times 10 to the 23rd, and you don't put parentheses around the times 10 to the 23rd, your calculator thinks you're supposed to divide by 6.02, and then the whole thing is it wants you to multiply by the 10 to the 23rd. It doesn't understand what you're putting in. So we'll get there, but be careful with it. What did you guys get?
2.68.
2.68 times 10 to the 24th. Good. Molecules. Okay. And 6 figs? Yeah, we're good. Okay. So that's all dimensional analysis is. That's it. But I want to show you more complex ones. That was a 4-step or 3-step one. There's some other ones with cubes and squares where you might have to convert just the denominator, just the numerator. So that's what I'm exposing to you. At least one example of each one so that you're capable of doing what you need to do. Okay. So remember this. King Henry died by drinking chocolate milk. ... Micro. ... Nano. ... Pico. Okay, so we're going to be referencing these at times. I would recommend you just have your paper someplace. So just write King Henry died by drinking chocolate milk. ... Micro. ... Nano. ... Pico. And then mega. So that's going to be your number line for today. Okay, so we're going to do a really simple one. And I know that you can do this via decimal swooping, but I want to get you to practice just dimensional analysis a little bit more, understand the scale. And fun fact, I think, did I tell you guys about the metric system? And when we're converting with the metric system, we ignore the metric sig figs. Did I tell you this yesterday? I mean, from my other class. Okay, because whenever you write down a conversion factor such as 1 meter, how many centimeters are in 1 meter? How many? So I heard one answer. I heard one person say it correctly. 100. Good. Because if B, which is meter, liter, and gram, that's the base unit, okay? If you're at B base and you put a 1 there and you're going over to centi, you would put 0, 0 here to hold their decimal places. So that would mean there's 100 centimeters in 1 meter. Okay? So that's 100 centimeters. So if I make this a conversion factor 1 over 100 centimeters, and I said how many sig figs are there, it's going to be 1. And it's going to be 1 in every single problem. And that would limit all of our problems to 1 sig fig, which is bogus, right? We're not going to do that. So that's what I mean by this. Ignore the the metric system conversion. You're looking mainly at the given for the sig figs, for anything like this, okay? And is this on your paper? This is on yours, right? Okay, perfect. I'm only going to do a couple from each set. I'm not going to do all these because I think you guys are going to be bored to tears. Let's start with the first one, okay? 3,500.0 milligrams is our given. I want to cancel out what unit? Milligrams, right? So I know I need to put what on bottom? Milligrams, and what unit on top? What unit do I want? Grams. Okay, so I can easily set up my units, but I haven't put my numbers in yet. And this is where I usually go to the number line. I'm like, all right, which is the bigger unit, gram or milligram? Gram. So at the gram, I put a 1, so that's at the base. I put a 1. And then millis over there. So how many millis are in 1 gram? 1,000. Some of us just know that, right? But if you need the help, you put 0, 0, 0 until you reach your second prefix. And that would say there's 1,000 millis in 1 gram. So 1,000 milligrams in 1 gram. So all we're going to do is put 1 gram, as you guys told me, 1,000 milligrams. So we're essentially taking that, dividing by 1,000. What's the answer? 3.5. Hold on. How many sig figs should this have? 5. 1, 2, 3 over 5, right? There's 5 there. So that 5 sig fig is going to be controlling our final answer. So there should be 1, 2, 3. Yeah, there you go. Grams. That's actually the final answer because this person did a great job. It's very, very accurate. Yeah.
You wouldn't use the 1,000, so it wouldn't be 1 sig fig?
Yeah, that's what I was just explaining with the ignore the 1 metric because all these metrics, they are always going to limit us to 1 sig fig. And so that is just helping us convert, and I'm having you guys practice metric system. That is not what we consider for the sig figs. It's the measurement itself. This is not necessarily the measurement. So yeah, that's going to be a 5 sig fig notation. And then the milligrams cancel here and there. Okay, tell me another one on this one that you guys want to do. 1 through 4. 3? Okay, so 8, 4, 3, 4, 5.6 micrometers. How do I set up my units? What goes on bottom? Micrometers or micrometers. And what unit goes on top? Meters, because you can see I want to get rid of that. I want to get to that. That's why I'm orienting it as is. And then how many micrometers here are in 1 meter? How many zeros? So it's 1 million, so it's 10 to the 6th. And that's because these dots here do hold places. So that's 10 to the 6th difference. So I usually I like scientific notation, right? So 1 meter is big and it has 10 to the 6th little micrometers in it. So you're dividing this number by 10 to the 6th. So that does mean you're moving decimal back 6 places that way, but I'm showing you both methods here. So that's 8.4346 times 10 to the negative 1. Negative 2. Yeah. Is that right? So this right here is scientific notation, but it should still be 6 sig figs. All right, so easy so far, guys? Yeah, some of us are like, let's move on. All right, so with our more complex units, we're going to just be using 2 types of units in the same conversion. So let's do number 6 right here. We're going to do just the numerator and then just the denominator, and then they'll kind of come out together as is. So we're going to start with 4.52 grams per milliliter. Write it out as a fraction, not as a slash. And I'm going to kind of just show you first. I'm going to stick with the unit of converting, or the thing needed to convert the grams to kilograms first, and then we'll do the milliliters to liters. So ignore this milliliter here for a moment. I want to get from grams to kilograms. What is the conversion, or what do I need to write next? I hear 1,000, but where does 1,000 go? On the bottom with what? Grams. Good. 1,000 grams is equal to 1 kilogram. As you can see from our kilo over here, to gram is, we're just base. There's 1,000. There's 3 zero differences. Zero differences there. So that allows me to cancel grams there and grams there. So now my numerator, I've achieved the unit of kilograms, which is what I wanted, so I'm good here. Now I don't want to touch that. I'm leaving that as is. I'm going back to the beginning and looking at milliliters, and I know I don't want milliliters. I need to get rid of it. So how do I get rid of milliliters? It's already on the bottom now. On the top of the next fraction that's coming over here. It's okay that there's something in the middle, totally fine. So I need to put milliliters on top here because they need to counter each other. And what is going on bottom here? Liters, because that's what I want according to the question. So now, what is the conversion between liters and milliliters? Right, so 1 liter is 1,000 milliliters. Okay, and before you calculate this, can you simplify this? First of all, the milliliters and milliliters do cancel, so the only units left are kilograms per liter. So we got our final unit, but what is the number? Did it change? No, it's 1,000 and 1,000. They're on opposite sides, so divided by 1,000 and times by 1,000, they actually cancel each other out. So the number is numerically the same, 4.52 kilograms per liter. Haha! But we did it via dimensional analysis. Okay. All right, thumbs up when you're good to go on to the next set of types of questions. Thank you. And you can smile with that too. That would be great. Thank you. Okay. Can I go forward? Yeah. No, I made that one special so you could see that you could simplify maybe without having to calculate. Okay, so these have actually, these are the ones that set we kind of already accomplished. It's basically, it says you have to go from the given to the base, which is B as in meter, liter, or gram, but you don't have to. You can go all the way, and we kind of already did one like that. So let's just do number 2, just to make sure we're good with that, and I'll move on. So I'm starting off with 880,000. What's DM? Decimeters, right? So I'm going to go from decimeters to what? Megameters, right? Sounds like a transformer or something. Okay, so what's going to go on the denominator? What unit? Decimeter. And what goes in the numerator? Megameters. All right, so this is where your decision is, who's going to get the 1? Who is the biggest unit? The mega by far, right? All right, so megameter is the 1. And how many zeros does it take me to get to decimeter? 7. 1, 2, 3, 4, 5, 6, 7. So that's 10 to the 7 that we would then input for the other numeric number on the fraction there. So that's how you use, you can cross the base. It's totally fine. So what was it? 1, 10 to the 7. So our decimeters canceled, and then we were able to go on and divide by 10 to the 7th. So that's like 0.088034. But I want you to notice something before I change this up on you, okay? How many 6 figs are in this answer, or this initial? 2. If I put a decimal there, how many sig figs would there be? So 6, right? But I don't have the decimal there. So that's saying these zeros are just placeholders. So that's 2 sig figs. So how would this be? How could this be changed to scientific notation? 8.8 -2 megameters. There you go. So 8.8 are our 2 sig figs here. Okay. So now we're going to do cubed ones because they require you to kind of do one extra calculation to show you that difference there. Okay, so let's look at, well, here we're looking at number 1. You'll notice I'm going from meters cubed to centimeters cubed. And naturally, you're just like, hey, we went from meters to centimeters. What's the conversion between meters and centimeters? How many? 100, right. Base is meter, centi is 2 zeros away, so it's 100 centimeters in 1 meter. 100 centimeters in 1 meter. That's actually a little different when you're doing cube things. So here's my process. Start out the same, and then go ahead and write out your units like we had been doing. So what do I put on the bottom? Meters cubed, and top? Centimeters cubed. Okay, so if I see the cube, you have to cube the numbers as well. Okay, so the 1, which we said was 1 meter, gets cubed, and the, what goes up here? How many centis? 100. That 100 is also going to get cubed. Because the unit is cubed, the conversion is cubed, meaning the whole shebang is cubed, and I show you that by cubing the numbers. Alternatively, you could write that as 100 centimeters over 1 millimeter. Sorry, not milli, just meter. And then you could just cube your whole fraction like that, but I'm just showing you I'm distributing it in. And that's it for those. It's not a huge difference, but it's a difference that most people forget. Like, that's the one on the test nobody gets. So I'm telling you now, I'm going to start on that one so that you don't forget through that process. So, meters cubed cancels. So then you're actually multiplying by 10 to the 6th, because 100 cubed is 10 to the 6th, so 8.004 times 10 to the 8 centimeters cubed should be what that is in scientific notation. And then you don't necessarily have to write down scientific notation. Okay. Or you could write it as like 8004 with a bunch of zeros. Okay. How about, do I need to do the squared one? Can you imagine what we do with the squares? Square the numbers, right. So if you square the unit, you are squaring the number with it. So what's the conversion between meters and kilometers? 1,000 is the difference, right? So 1 kilometer, which is huge, right, contains 1,000 meters. So if this was your conversion, actually, yeah, this would be your conversion. You could either square the whole thing, or you could square each part of it. So just don't forget that one key step. Yes?
So you don't have to square like the original number?
Nope, because it is itself is designated as is, but with its squared unit already there. Okay. Okay. Let's do one more type. They're not bad, but they're like the changing of the numerator and then changing of the denominator. I'm going to go with converting number 2, okay? So we're starting in centimeters per hour, and we're going to millimeters per second. So starting off, write it as a fraction. And I want you guys to worry about the numerator first, ignore the denominator. So how do I get from here to here? What goes on the bottom? So I'm going to put centimeter, and I'm hearing 1, but wait on that for just a moment. What goes on top? What unit? Millimeter, because we're going from centimeters to millimeter. Okay, so now you tell me how many, which is the bigger unit? Centi, and that's where you're telling me 1. And how many little millimeters are in a centimeter? 10. And you can even think back to a ruler. There's 10 millimeters there. Or you can see on the number line, there's a 1 0 difference, so it's 10 difference. Okay, so centimeters cancel. I'm in millimeters, and that's what I want, so keep that, don't touch that. Now how do I handle this guy? Right, I have to go across that middle part, put hour on top and 1 on bottom. Second, because I'm going from hours to seconds in the denominator. And then what's that conversion? Good. 1 hour has how many? I heard it earlier. 3,600? Because technically 1 hour has 60 minutes, and then in 1 minute there's 60 seconds. So 60 times 60 is 3,600. But we kind of, some of us did in our head, that's fine. So the hour here and hour on top will cancel because they're counter to each other. Seconds are in the denominator, which is what I wanted here, and then I just calculate. So I would do in my calculator 4.06 times 10, which is 40.6, divided by 3,600. That one I can't do in my head. 0.01127. Okay. Millimeters per second. And how many sig figs should I have? For these, for anything that's using metric conversions, or like our time here, I want you guys to stick with the sig figs that I give you, and that's going to actually be a lot easier. So I'm having, how many sig figs are here? 3, so that should be rounded to what? 0.013. Right, because that 0 in the front is a leading 0. Does it count as a sig fig? Okay, so 113 millimeters per second. Okay. Let's see where we are. Look at the questions. Look at the mixed questions right underneath the complex units. And I want you guys to pick 4 of those to work on for the person next to you. Okay, then we'll talk about the work on the wall. Pick 4 together. Mixed ones, I'm sorry.
I thought we were done.
Oh, okay. Oh my God.
Yeah, the minutes is the biggest one.
Millimeters squared. Millimeters. It's like the cubed one, except just.
Yeah, but like what? Oh, yeah.
When the base was increased,
That very first one that has an invisible number is a 1. It says 1 millimeter squared.
millimeters the last one. So. The last one is millimeter. What is the first one?
Like the base would be
Oh yeah.
gram, so it would just be 1,000.
You have to square the bottom of it.
It would just be one. It would just be one because like
Put it up here.
I was supposed to do this on the Oh, I was making sure that was okay, sorry. Yeah, you're right.
It's the one after. I think it's
Well, the grants will still be the base. No, the smaller ones on top. Well, yeah. You're right. Okay, there's no sweat.
no, that doesn't matter.
How many
Oh, I found it.
And then you have the two
Okay, I just really
No, I'm just writing it for your sake. All right, just keep checking yourself on the board. I will write, or I can do whichever ones you need me to. After you are done, you can start the word problem. After you're done, you can start the word problem. Just a complex, right? I'm gonna write down the answers to complex ones as for the word problem.
I'm not sure.
I think it would be about. How can you tell that? I always like the one big dollar. I'm not sure. Yeah, because like they won't. This isn't too loud. Yeah,
You guys okay?
Because like it seems too much in like. Oh, this will be the meter 3.
And then use your conversion. Actually, right now,
What do we?
that actually has
Oh, so if there's like a zero, like after like the green, then there's a zero.
wait, that's not the placeholder. All these zeros don't count. Alright, is everybody good for me to start one of the word problems videos? Have we accomplished our 4? I just want to make sure I time you around, Brian.
Yeah, because like it's
I'm going to do number 12 from the word problems. Here we go. And I'll put this back up for you as needed. I need you guys to read me the question, because I don't have my question sheet with me now. Oh, no, I do. I lied. I do. It's right here. Thank you. I appreciate it. That's where I had it. Okay, and so I walked you guys through the very first day, or the first slide for today, how to approach a problem, right? I'm going to give you like a narrative to read, and you don't need to read the narrative. You need to look for the given, the conversion factor or factors, and then the question, right? So in number 12, a sample of seawater contains, boom, what is that number right there? What of the 3 characteristics of a question? That is the given. 6.277 grams. I lied to you, I didn't finish reading. Sodium chloride per 1 liter of solution. How can we write that better in more mathematical way? 6.277 grams per 1 liter. Okay, so an SLO in a solution. That's a conversion factor because it has a fractional unit to it, okay? Sorry, I didn't read ahead there. Okay, so how many milligrams? So stop there. What is that telling me or asking me? Say it again. So it says how many milligrams. So that's my question, right? I'm looking for milligrams. That is the question. Okay? And then how many milligrams of sodium chloride would be contained in 15 milliliters of the solution? What is the 15 milliliter part? That's the given. Thank you. So this is the conversion factor. This is the question asked. And the 15.0 milliliters is my given. And what do you start with? The given. Okay? So I'm starting with the given. I see milliliters here. Do I see milliliters anywhere else? No, but I see a version of it, right? What do you see? Liters. So if I see liters, my first instinct is that I need to take milliliters to liters just by metric conversion. So I can then implement this conversion factor because that's the only way I'm going to get to mass. So what is my first step? What goes on bottom? What unit? Milliliters goes on bottom. And what did we just say we need to convert to? Liters. So what is the conversion? 1 liter has 1,000 milliliters in it. Good. And so the milliliters cancel. Now I'm in liters. Big whoop. What do I do with that now? Use that thing. What is that thing called? The conversion factor. And do I write it as is or do I flip it? Why as is? Because I have liter on top here and I need to have liter on bottom here in order to cancel. Good. So you should have reasoning behind our choices, right? I'm choosing to put the grams on top and liter on bottom. And I'm not just writing it just because that's how it is. It's because it works. So a liter on the top there, a liter on the bottom there. They cancel. Now we're in grams. We're so close. I need to get to milligrams. Notice I haven't referenced the paper at all. Don't even read the question again. If you write down your conversion factor, your question you're given, you shouldn't have to read the question again. Because it sometimes gets confusing to do that too many times. All right, so what is your next step? I hear grams on bottom, milligrams on top, and who's the bigger unit? Gram, and gram gets the 1, so how many little milligrams are in a gram? 1,000, because there's 3 zeros that separate them. Okay, is there any way before I calculate, is there any way to simplify? Thousands. So, oh, sorry, I forgot to cancel my grams, just my grams. So I'm stuck in the unit of milligrams, which is what I want. And this 1,000 and this 1,000, they cancel each other out. So in my calculator, what am I doing? 15 times 6.277, and that's it. Tell me you guys what your answer is. $94. 155 milligrams. Okay. How many sig figs does that one need here? 3, because I have 3 sig figs here and 4 sig figs there. These other things are metric conversions, ignore them. So that's going to be recorded to, what would you say, 3 sig figs, so 94.2 milligrams. There we go. So I just wanted to show you how to approach some of those word problems. On the word problems, how about we just do, so omit 15. You guys do 10, 11, 13, 14. I just number 12 word for the word problem section.
Oh wait, I did.
We start with the 45. The gram has a base, so the gram.
No, this is okay, here's your erase this one. So since that one.
I know it is supposed to be something. Yeah, okay, yeah, they could be. Yeah, that could be. Oh, do you not? Yeah. Yeah, because it's
I'm doing mine right here. You're not.
yeah, that's pretty. That's what we got to use. I believe so because like you know how this one like they don't have I think we use
Yeah? Alright. Keep checking yourself as you go. Pat yourself on the back. When you're done with these, you can start your homework.
Oh, we left out the
I'm coming. One second. You're second.
I'm trying to look at the other one.
How much iron do you know?
Yes.
You guys are in hot water. I'm talking about from Avery.
Somehow not put in if we don't know like how to
So one more.
like my other was like
Oh, I so did you say the 1.3 or do you want to put 11.3? Good try on that.
I kind of understand, but then
Yeah.
I mean, first thing you do, it says it's too. Yeah, so you put water is 18.
and then we would have to round and then we would have to round it up to just
Miss Edlo?
Yes.
For number one.
okay, yeah, pretty much my next one.
Yeah.
It says 7.
We had to round it up to 6.
You did like a 7.5. Yeah.
Let me look at it in just a second. I gotta pause this video.